That's your cerebral cortex looking for an answer it doesn't have.
See? Even your brain knows you're screwed.
The body's filled with adrenaline right now, whether you know it or not. Your heart's beating fast. It's getting a little harder to breathe. The neurobiological system is telling it to run, but your knees are too weak to move.
Fear is not real. The only place that fear can exist is in our thoughts of the future. It is a product of our imagination, causing us to fear things that do not at present and may not ever exist. That is near insanity. Do not misunderstand me. Danger is very real, but fear is a choice. We are all telling ourselves a story.
You're listening to Revolution Radio at freedomslips.com. 100% listener-supported radio. Reporting the danger. Unafraid. Right here, where information never sleeps. Revolution Radio! The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
And we're back like crack. You can see my lovely partner, Leah, who is both lovely and amazing. Look at those glasses. I should have had mine on. I got
struggling for some adjectives, huh?
Well, today we are doing another episode of Cosmic Catastrophe. Leah wasn't with us last week, but I did a very interesting show on the flood of Noah. Did you watch that?
Actually, I didn't.
Okay, well, maybe we can get you up to speed here.
Yeah.
What we're going to be talking about today is a more recent cosmic catastrophe, and it's what we want to get to the bottom of today, and we want to bring your attention to is the fact that in recent decades, astrophysicists, geologists, astronomers have been under the supposition that large cosmic impactors happen on very large timescales, 10,000, 100,000. In fact, most of them, if you asked like 100 astrophysicists across the field, when the last major comet impact was, they would push it back millions of years. When in fact, what we're finding is that cometary impacts happen more often than not, specifically November 17th. And today we're going to be talking about, and the November 17th impactors, those are the Torrid stream, and they might very well be responsible for a lot of the things we've talked about, the Hopewell airburst, the Younger Dryas event, and many others. But today we're going to be talking about Halley's Comet, and Halley's Comet has instilled fear in the masses for millennia, and it, in fact, may be another cosmic catastrophe impactor because the remnants of Halley's Comet are referred to as, Leah?
Oh, I've forgotten the name already. The Eta Aquarid. Here, I cheated. I looked at an article.
It's the Eta Aquariids, I think. Like Aquarius? Aquarius?
Yeah, but it's Aquarid. Aquarid.
Eta Aquarids. So they're obviously emanating from Aquarius, which is where the Halley's Comet debris field is. Now, depending on how thick the debris field and how big the debris is, it could mean nothing more than a nice little show in the middle of the night in the form of a meteor shower, or it could be more impressive, like a giant bolide like Tunguska, but maybe not just one of them, maybe two, maybe six, maybe 18, like Shoemaker Levy 9, which was probably actually 9 because that's what they called it. And those are the impactors in Jupiter. So today we're going to be talking about the potential for two impactors in the Gulf of Carpentaria. And the reason that they have come to this conclusion was a sequence of events. At first, They found some weird chevron dunes on an island in the Gulf of Carpentaria. And the people that first found those, the geologists explained them as wind-driven dunes, and which has been the mistake all around the world from independent scientists. And when other people, starting around 15 years ago, started looking at them in a different way and started kind of like the Carolina Bays, taking trajectories on these chevrons that they were pointing towards something, which would be an incoming mega tsunami. And this mega tsunami would be, well, gigantic and directional. So if an object comes in at a low angle and hits the ocean, it pushes the water and that wall of water away. So that's where you'd get that mega tsunami effect. On the back of the impactor, you'd get less of an effect, maybe no effect, because of the way it's pushing forward so much.
Sure.
And so these are huge events that can wash up. I mean, there was evidence that we've talked about of 10-ton boulders being hundreds of feet above current sea level. And you need lots of force to move something that large vertically, first of all, or tumbling it up topography. So just incredible forces we're talking about. Do you want to add?
No, I was just thinking about looking at the, if you look at Google Earth and you start looking at those chevrons, it becomes very obvious that they're not wind driven simply because you're looking at chevrons from a wide area and they're all moving generally in the same direction. So wind doesn't really make any sense to explain those.
Yeah, and there are some independent researchers that you can find on YouTube. I forget the name of this guy. Peter Zelinka. I think that's his name. He did so if you use Google Earth, they have old versions and they have newer versions where you can actually separate the time frame for about 40 years. And you can look at these dune features and see that they are barely moving because of the wind, meaning they're more permanent features that were already there. And if there's any change to them by the wind, it's secondary and doesn't really change the feature much. That makes sense. And it's been proven by looking at historical pictures going back almost to the 1800s in some cases.
Well, also the magnitude of the features, again, kind of, it's exactly what you were describing, that Zelinska, it's hard to not say that.
I think it's Zelinka, Peter Zelinka.
Zelinka?
Yeah.
It's hard to not say that other name that's been in the news a lot. When you look at the magnitude of the chevrons, kind of like also what you were talking about with the, a boulder that's been pushed way above sea level, obviously that can't be wind.
Yeah, so now what happened, let's say, in around 2004, some people started to find impact material in the Bay of Carpentaria, and then some of the people that were looking at the chevrons realized that those chevrons are pointing towards these impact structures. It's the same story that I talked about with Burkle Crater and the flood of Noah, that all the chevrons were pointing to a place, and at that place, they went and took some samples deep in the ocean, and guess what? There were impact, the microspherules, microgranules, and we'll talk about that. So not only is there a mega tsunami happening, and we'll talk about that, and we'll show the features to people that watch the video, it changed the climate. And I want to get into this. You can see the screen, can't you?
Yeah.
Okay, before we get started, I've always been wondering, if you look at high-resolution temperature graphs of the Holocene, what all these dips are. There are so many dips so often at huge magnitudes. We're talking 1 degree C, and they happen every 250 years. Now, it could be grand solar minimums, right? Because we have that kind of dynamo in the sun, but some are bigger than others. And many of these that we've been talking about correspond to cometary impact. Yep. The flood of Noah and Burkle Crater on this graph, that's at 2708 BC. So that's going to be 4,700 years ago. And it's right here. It's the lowest temperature dip almost on the entire graph. And that's when the Burkle Crater, Noah's flood, occurred. A comet impacted the central Indian Ocean, pushing up so much vapor into the atmosphere, it was probably dark for years.
Yeah.
And the temperature in this case plummeted 1.2 C. That would starve out everyone, literally, or you'd have to move in this case. And the impact The impactors we're going to be talking about today are here. Oh, do you like my new cursor? A lot of people.
Your yellow cursor.
It's
Make
giant.
it easier to see.
Yeah, it's giant because a lot of people have been complaining they can't see my cursor.
Ah, well, I can definitely see it, so that's good.
So the late Neoglacial anomaly, unexplained, right here. Do you see that huge dip?
Yeah.
Yeah. This is the Dark Ages. This is where all the
Yes.
myths of dragons and strange things come from. And it's the Black Plague shortly thereafter. It's right in here. This is the impact, literally, probably on that first drop down.
Yeah, and the estimation is that the temperature drop was about 3C, correct? Is that what that graph is showing? That looks like more than 3C. I can't quite
No,
tell.
these are half a degree. So that's
Okay.
a little bit more than 1C.
Yeah.
But
Some
still,
of the other papers that I looked at, they do estimate about a 3C drop.
Well, this graph is coming from a different source, not from that study. Yeah. So when you look at other graphs, here's one that's just the Mascar Strait water temperature of the Holocene. It does show up here, but it shows up lesser right here where Rome fell.
Yeah.
So Rome falls at the same time this impact occurs.
Not a surprise.
It's nowhere near, this impact is nowhere near Rome. So they may have seen it coming in the form of a bolide, but they wouldn't have heard it unless they could have heard it or felt the shockwave perhaps. But none of the tsunami waters would have gotten anywhere near Rome.
Right.
Yeah, so that's what's interesting about this. Now let's talk about, well, before we get specific about how Halley's Comet caused this famine in around 500 AD, I want to talk historically, and you could chime in here, about flood myths. Because we're not just talking about Noah's flood. When people talk about Noah's flood, they typically are putting in all the flood myths into one pot. Do you agree with that?
Yes.
Yeah, so we're not talking about one flood. And in fact, what I think is going on is that floods are so pervasive, and these mega tsunamis, these catastrophic flooding events, there was one initial flood story, and each time it happened, they rewrote it, and it's happened again and again and again.
That's what it seems like to me as well.
Yeah.
Because clearly there are flood stories from around the world, and they may very well be from different time periods, but it sounds like the same thing, so we tend to lump it all together as if it only happened once.
Well, no, just to get it out on the surface, how obviously the dating is bad, is that we have the one flood myth of Atlantis that's coming directly from Plato, and that puts, specifically, we can date that to the Younger Dryas event. 11.5 is the date if you use the numbers. But if you use the biblical text, the Noah's flood, that gets dated around 5,000 years ago, which is exactly Burkle Crater. That would be 4780 something BC.
Yeah. Yeah,
so clearly two different floods, the Younger Dryas and a different thing 5,000 years ago, are two different floods. Now, floods in the wake of the late glacial period are speculated to have inspired these myths. And what we just proved here is that they're different floods. So Plato's allegory of Atlantis is set over 9,000 years before Plato's time. And that led scholars to suggest that there was an ancient Stone Age society that lived close to the Mediterranean Sea that could have been wiped out due to rising sea levels, because the seas came up 300 feet. So we know that from ice core data. In Mesopotamia, like other early sites, which are riverine civilizations, they're not on the coast, but they are on rivers. These rivers were extremely flood prone. And there are things called the 5,000-year flood, where the river comes up 180 feet. And so if your city gets flooded for 3 years, it's a flood. There's another flood myth.
Yes.
And then we've got the Burkle Crater hypothesis that suggests a meteor crashed into the Indian Ocean, 2800 BCE. And in that position, it would have pushed a mega tsunami directly up into the Fertile Crescent, up into the Nile Delta, and it would have been literally into the Bible cities, a biblical flood. But this is a mega tsunami, so you would just see a wave of water. You're inland 8 miles, and this wave is coming. It would have been insane.
Yes. Sometimes I think that we assume that the flood only happened once, let's say, because we really want to believe that conditions on Earth are really stable. But I think the evidence is showing the contrary to that.
Yeah, we're going to show some evidence and talk about it, that these mega tsunamis happen all the time. When we're talking geologic timescales, they happen all the time.
Mm-hmm.
So in our lifetime, we should potentially see a mega tsunami because there really hasn't been one. We had a tsunami about a decade or more ago in Indonesia that was 60 feet high. That killed hundreds of thousands. But that is not what we're talking about here. We're talking about something 10 times bigger.
And that was huge. I mean, that tsunami was devastating.
Imagine if
but
it was 10
wasn't nearly
times
as
higher.
big as it could have been.
What that does is it wipes all of the buildings away. There's nothing left.
Yeah.
There would be nothing left.
Yeah.
It makes it easier for cleanup because it's already cleaned up.
Yeah.
There's even a strange, an older hypothesis that I remember from university called the Black Sea Deluge hypothesis. And this comes from some geomorphic work and geologic work. And this one is a hypothesis that argues for a catastrophic eruption with an I, not E, an eruption of water 5600 BCE when the Mediterranean Sea broke through a topographic high and flooded into the Black Sea basin, forming the Black Sea. So anyone living in that fertile valley would have been under an ocean in an instant as the Mediterranean erupted into the Black Sea basin, forming what we now know today as the Black Sea.
Very interesting. Is there a hypothesis about where the water rushed over the land? Is there evidence on the land?
On a specific spot and what happened. Yes.
Yeah.
Yeah. So that's kind of interesting, but there's lots of controversy over all of these obvious flood myths.
Yeah.
Now, what we do know is that giant meteorites slammed Earth around AD 500. And in AD 500, we have this massive drop in temperature, which is known as the late Neoglacial anomaly. When temperatures dropped on Earth, this is an on-Earth graph, at least 1 degree C, which would have caused crop loss and famine and other things. Now, I'm going to read an abstract from which will get us all up to speed on the largest natural catastrophes in the Holocene and their possible connection with comet or asteroid impacts here on Earth. And the paper deals with the physical and environmental effects that result from ocean impacts by sizable comets. And they also talk about the rates and risks associated with such cosmic impacts. And what they conclude is, what do you think they conclude?
Well, I don't know what they conclude, but I have noticed in the literature that there's kind of a bias about how often impacts actually happen. Like people are saying, oh, well, we've calculated how often they should happen, so this hypothesis about an impact must be false. Well, so I'm guessing that they're underestimating. Maybe not.
We can nip that in the bud here. Take a look at this graph. Now, there were studies in Australia where they used, let me see if I could pull it up here, Aboriginal information. Here, Australian Aboriginal Geomythology. Ooh. Eyewitness accounts of cosmic impacts. So not only do they have the eyewitness accounts, but there are lots of known impacts in Australia. Let's just pull up the map here. This is the geographic location of known terrestrial impact craters in Australia. There's almost 30 known.
Yeah.
And many of these correspond specifically with eyewitness accounts in the direction they came in and then the object they found. And so here's a graph which shows the absolute magnitude of these objects. Here is Tunguska on the left. And this is the size and diameter down here, small. It's less than small, 1/10 of a kilometer. And here is the KT impactor that extinction of dinosaurs would be at the high end. This would be a 10+ kilometer rock. And if you look at the impactors on Australia, they're huge.
Yes.
Some of them are 9 kilometers there.
Yeah.
And then we have an 8 kilometer, a 7.65 kilometer impactor, a bunch in the 1 kilometer range, but they're all much bigger than Tunguska.
Yeah.
And many of these are recent.
Yeah.
So, There's
That's
the data.
interesting too, because the 536 event that we're going to talk about, the estimation of the size of the impact of that was only like 600 meters or something. But
yeah, there's two craters. We're going to get deep into them. And this abstract here covers it pretty well. So in the paper, they investigate two sets of probable oceanic impact events that occurred within the last 5,000 years. The one I talked about last week in the Indian Ocean, which is Burkle Crater, and the other ones we're going to talk about in detail today, the Gulf of Carpentaria, which is in northern Australia. And these happen in 536 AD. And if these are validated by science, which they're not, they're still arguing, they would be the most energetic natural catastrophes in the last 5,000 years. Such large-scale impacts on Earth would be environmental and historic human effects and consequences, meaning a whole reworking of what's going on. So one day you're doing what you're doing, and the next day it all has to change, because not only is it dark, but it might rain for 8 months and everything. You're not growing food. You've got to come up with a new plan.
Yeah, the whole ecological system is going to shift dramatically, even with a difference of only 1 degree C.
Yeah, because it's not like it's hard to understand that how much that changes the temperature. An average change of 1 degree C is much different than it just being 1 degree C cooler.
Yes.
Yeah.
Yes. That's a very important distinction to make.
Yeah.
Right. It's the difference between weather and climate.
Yeah. And some people think in an ice age that there isn't summer. There's summer in an ice age. It gets warm out during the summer.
Sure.
It just doesn't get warm enough to melt the ice that built up from the winter.
Right.
All right. So let's jump into the physical impacts, or the physical evidence for these two impacts. They consist of remarkable depositional traces of coastal flooding, including the chevron dunes that we'll take a look at. These are found in southern Madagascar and along the coast of the Gulf of Carpentaria. And if you look along the coast of almost all continents and you know what you're looking for, you're going to see massive tsunami deposits in the form of huge wash-ups of sand. And it's not an ancient coastline. So, if the sea level was 100 feet higher, it would be obvious what an ancient coastline would look like if that were to be what you're looking at. But when you're looking at a localized area where there's only a section of sand that is blasted in 30 miles, that's not from sea level rise. It's from a wave.
Yeah.
Let me see what else they have. Okay, so these two craters we're going to be talking about are called Canmare, which is 18 kilometers wide, and the Taban crater, which is 12 kilometers. Is that what do you think the pronunciation? Is that correct? Canmare.
I can't actually read that on my end. It's too small the way I'm viewing the share screen. So.
Oh, okay. Now they got some carbon-14 dates here, and they dated 572 AD, plus or minus 86 years. There was the presence of high magnetic susceptibility. There was quenched texture magnetite spherules and nearly pure carbon spherules. There were teardrop-shaped tektites with a trail of ablation. That simply means that you get that from impact and splatter and instantaneous quenching. You get these tektites with tails. They look like comets almost. Yeah.
Could you explain the first condition that you read about? You said magnetic something or other?
The presence of high magnetic susceptibility.
What does that mean?
There's magnetic grains that are found there.
Yes, okay.
Yeah, unique to the magnetic condition in the area.
Sure, okay.
So if you test the magnetic field of all the rocks around it, they usually point somewhere, and then you get to this crater, and they're all over the place.
Right.
Yeah. And then, of course, the V-shaped chevron dunes. Yeah, okay, what else can we... Yeah, so there's all kind of impact evidence here. And they did some core samples. They did 1 centimeter thick 3-piston cores And then here's a third line of evidence is that the local chevrons all have back azimuths that, guess what? Point to all the candidate craters.
Right.
So it's just like the Carolina Bays all point back to where the impact hit the ice sheet that then shot off the secondary pieces of ice. This is showing the direction of the impact crater, which is the mega tsunami coming right at that spot.
Yeah.
And can you imagine being there when it occurred? Well, you wouldn't have made it.
No, it's really hard to imagine.
Yeah, the results of the study show that the substantive oceanic comet impacts not only have occurred more recently than modeled by astrophysicists, but also that they have profoundly affected the Earth's natural systems, specifically climate and human societies. And this could potentially lead to a major paradigm shift in environmental science by recognizing the role of oceanic impacts in major climate downturns during the middle to late Holocene that have already been well documented by using different techniques like tree rings, but there is no mechanism, you know? So people are like, it's the sun or whatever. No, it could be an impact, and they could be happening quite regularly. Take a look at that.
That's amazing.
You can see that graph.
Yeah. And for our audio only listeners, what's the full time scale of that graph? Because there's probably
last 11,000 years, as soon as it got warm.
So there's probably
coming out of the Younger Dryas.
At least 50 potential impacts in there, if not more.
And we'll get into more specific talk about impacts after the break, and we'll bring up Google Earth and we'll have a chat.
Revolution Radio at freedomslips.com, and we'll be right back after this message.
Who owns you? If you're not in control, then someone else is. Join me, Ivy West, for Voices on the Wind, Saturday. I discuss government, health, metaphysics, suppressed science, universal mysteries, little-known incredible facts, alternative energies, and even more than you can imagine. There was blood on the wire. Won't you join us on Revolution Radio Saturdays for Voices on the Wind with me, Ivy West. There are lives in the balance, people under fire, children at the cannons. Because if your head's in the sand, your tail is a target.
Thank you for listening to Revolution Radio at freedomslips.com, the #1 listener-supported radio station on the internet. Please help support this station so this battle can continue forward. Revolution Radio!
Join me on the Brian Ruhe Show on Revolution Radio, Eastern Standard Time, every Tuesday night from 6 to 8. We talk about the four most vital things, in my view, affecting all of humanity. Number one is UFOs and aliens and their agenda for the advancement of humanity. Number two is the Jewish establishment's control over all aspects of human civilization. Number three, the truth about Adolf Hitler, how he was the opposite of what we've been told. Number four is advanced ancient global civilizations. Join me on the Brian Ruhe Show, Tuesday nights from 6 to 8 on Studio B on Revolution Radio.
Thank you for listening to Revolution Radio at freedomslips.com. Any commercial advertising you may hear in this program is of the sole discretion and benefit of the host of whose program you are listening to. Revolution Radio does not endorse any commercial products, nor does it accept monetary compensation for on-air advertising of commercial products, nor will it ever. We are and shall remain 100% listener supported. Any product advertising on this program are considered used at buyer risk, and Revolution Radio shall not be held liable for any claims or damages received from any product advertised within this program. Revolution Radio, where information never sleeps. The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
And we're back, ladies and gentlemen, for the second half of Cosmic Catastrophe. And I love that fake audience. What about you?
You really do.
So we've been talking about cosmic impactors now for 6 weeks. It's becoming ever apparent as the show moves on that these may be happening more often than many people think, including the top experts in the field. And quickly, we are becoming the top experts in the field. Very few people have gone over the literature in the context that you and I do, and people like us, where we look at the historical context, in this case, the Aboriginal eyewitness accounts, and everything is coming together if you have an open mind and you're willing to look and continue to look. You got nothing to say on that, huh?
Well, I was thinking about, again, what I said earlier about, certain academics saying that there shouldn't be this many impacts because we don't see, basically because we don't see them out in space. So my question is why are we not, if you're making a calculation about how often the Earth would be hit and we're missing some objects, why are we not seeing them? Are they just too small?
Well, we're getting better at it. I just reported the fact that on the 19th of November was only the 6th asteroid ever detected before hitting Earth. And it was only detected several minutes before it hit. So that's how good we are. So we detected 6 asteroids moments before they hit. And this, well, it does 2 things. It gives you more information on the trajectory, and it's very easy to then go find the pieces. And in fact, they had they detected it so early, they had like a 3 square mile region where the pieces were. They put it up on a map. Everyone, because it's like it was like in a suburb, people went out in their backyard and literally found pieces of the comet or the asteroid just sitting in the grass.
Yeah.
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 So
I mean, I was laughing because it just shows that we're just the very few asteroids that we've detected coming in. It just shows that we're really just not like you said, we're getting better, but we're not very good at it. So the fact that people are making arguments on that basis that some of these things aren't impacts or shouldn't be because we think the number of impacts should be much lower, that's ridiculous.
Yeah, they're like non-impactists.
Yeah, that's not an argument. It's not.
Well,
like,
and the general consensus in science that people have been brainwashed with uniformitarianism. I was, but when I learned of it as an undergraduate, I immediately picked my mentors, the 2 geology professors there, that were anti-uniformitarianists. They were catastrophists because when you look at the rock record, it is a series of catastrophes. There's nothing happening that's all hunky-dory there. Specifically when you look at the rock, and it's been going on for all of geologic time, where environments are rapidly shifting about every 26,000 years from one thing to another, and again, and the shift continues to happen again and again, and it's catastrophic for any person sitting in one single area. The shift in environment would be so catastrophic in one of these cycles that you would have to move. And so that is the nature of humanity for the last 100,000 plus years is people have had to move around. They haven't had a lot of time to sit put in one place. Let's take the Hopewell, for instance. They were there for 1,000 years building all these mounds and they're not the Hopewell people. I just want to, that's what the scientists name them. So it's whatever those people called themselves during the Hopewell period, they got taken out by a comet.
Yeah.
And they certainly didn't stick around. And this is interesting. If you follow, I've been doing some research. I'm going to do a video on this. If you follow the mound building effigies, they start near the East Coast and they move west. And after the Hopewell event in 400 AD, the mounds move further west, and then Cahokia is built. The largest pyramid in North America is built after the Hopewell event destroys that effigy building culture there. They move away and they do it even bigger.
Yep.
So these are all the same native groups. They're giving them different names. It's kind of amazing.
Yeah. Well, it's interesting too, because the whole uniformitarianism bias, I'm just going to call it that and coin that term because that's really what it is. I mean, it doesn't just come up in terms of the bias about that. It just doesn't come up looking at the rock record, but it's still being used now to be alarmist about anthropogenic global warming, right? Because if you don't look at the prior history and see how many severe changes have happened in the past and how much more extreme things have been in the past, and you just look at, something that looks very consistent and then is, supposedly starting to rise a little bit, it's going to look very alarming. So it's like that same bias is being used to perpetrate other falsehoods. And the fact that it's continuing is just crazy. Your mic is on. You're muted.
I said, just take a look at the graph here of the Holocene. And if you get an honest graph, it shows that we're colder than it was in the past.
Right. Right.
But none of these honest graphs exist anymore. And as far as the two craters in the Gulf of Carpentaria that we're going to be talking about, they were discovered by undergraduates in 2004. And this was what spawned all of this. So these undergraduates were studying evidence from tree rings, which suggested that the Earth underwent a series of very cold summers around 536 and 540 AD, indicating an effect rather like a nuclear winter. Now, that is a major climatic catastrophe.
Yeah.
Yeah. And that's when the science began. And then there were magnetite and silicate spherules found in the GISP-2 core. These are in Greenland.
Yeah.
Okay? Not anywhere near the Gulf of Carpentaria. And these were at the 536 AD horizon, suggesting that this comet came in multiple pieces. Probably a bunch of them hit all over. Most of them small, burned up before they hit the ground. But they saturated our atmosphere, our mesosphere, with magnetite and silicate spherules, cosmogenic material that then rained down on the Greenland ice. So this is not a tiny event. This is a global event, but the mega tsunami was local.
Yeah. And
would have been amazing to witness. And some people high enough in an area could have witnessed this.
Sure. If you were high enough up on a mountain, you might have seen it and survived.
Right. So if you watch the video, all the links to all these papers will be there, so you can check our math. But accounts from a distant past have recorded stories of a global climate cooling event that lasted 18 months in March of 536 AD. And this was known as early as 1984. So these are historical accounts that still exist. You just go into the ancient literature and they talk about this.
Yeah.
They talk about it globally. So this is coming probably out of Europe or England, which is nowhere near Australia, but the event happened in this bay in Australia.
Yeah.
Pretty interesting.
Which I find amazing to think about when you consider that this object may have only been 600 meters wide. That's not that big, but it has global consequences. It's huge.
Well, impact doors, because there's two craters.
Sure.
They're approximately 600 meters. The rock, that's gigantic. Think about how big that would be if you put it in your front yard. It's a quarter mile wide.
Right. But then you compare it to the size of the craters, right? 18 kilometers and 12 kilometers.
Yeah.
I mean, it just goes to show the effect of something coming from outer space. The amount of
and it's a quarter mile wide, and it's going to go right to the. So the one that hit the Noah's flood, the Burkle crater, it displaced thousands of feet of ocean water and hit the bottom.
Yeah, that's the other part that's amazing, right? Because you also have to go through all that water, so just the force involved is enormous.
Yeah, these are
like no wonder it has a global impact.
Hitting the bottom of the ocean, and they probably then cracks the earth. It rings the earth. It triggers volcanic eruptions and earthquakes, and then it gets dark. So you think it's the end of the world. I mean, it's literally the apocalypse, and it's happening every few hundred years on Earth. It appears.
Right. Like no wonder that human beings talk about fire and brimstone and hell on earth and all of this stuff. Like this is not made up. It's not just from our imaginations. This is genetic memory. This is real.
Yep. And some people saw it happen. Yeah. It's really interesting to read the paper on the eyewitness accounts from the Aborigines, and we'll go through some of that if we have time here. But the two crater candidates we're talking about in the Gulf of Carpentaria is Canmare and Taban. These are the two impact structures that you can look up on the interwebs. And they may have been the sites of a comet impact at the exact time of this climate cooling event. So that is pretty interesting. And so here we are at Australia, and we're going to just take a look up here. This large opening in the north is the Gulf of Carpentaria. And the location of these craters are right near Mornington Island. So the one crater is off the shore here to the west of Mornington Island, and the other crater is down here near South Wesley Island. Neither you can see with the bathymetry or the seafloor mapping here because it just doesn't exist.
Yeah.
But if they're coming in at an angle, and the first thing you want to notice, if you pan out, is the amount of sand right near the area that goes inland here in the bay. Mm-hmm. So that's going to get an immediate blast of a tsunami instantly right here on the other side. And if in fact they were coming in a direction at an angle here like this, like the pointer is pointing, it's going to send the mega tsunami off this way. So none of these shores are really going to be greatly affected, but the things over here are going to be smashed. And this is where they noticed these chevron dunes. Take a look as we're panning in right here, the amount of sand in this bay that is miles inland.
Yeah.
And as you come in on it, you start to see these chevron features. The same features in India that go inland. Let's just take a measurement on here. That's 2 miles. Wow. So it washed directly across that island or that peninsula. And that would take a pretty big wave. And then when you start to come in these forms are massive. So let's just take a measurement of cross one dune here. 600 foot wide ripples.
Yeah. that wasn't wind or just regular old water waves, clearly.
And they're pretty massive. And you can see here, if we go in 3D, this is very high up. So it washes the sand upwards. We can't really I don't know how to use Google very well.
It'd be nice to know what the elevation is there.
Yeah, I think I have to buy the fancy version to know that. But these go all the way up the shore here, notice? Mm-hmm. And way inland. I mean, let's see how far this chevron is inland here. 2 miles.
Yeah.
And the chevrons all the way on the other side of the island, right here, see where I'm pointing?
Yeah.
Are still pointing coming from the east.
Yeah.
So the water washed, and here's a chevron right here that's still from that tsunami. So the tsunami came over the entire island here, or the peninsula. And then if you angle these chevrons back, they're going to take you back to these islands.
Yeah.
So if you were to they take you back right here to where the impact was. Mm-hmm. Yeah. Now, one of the eyewitness accounts, wow, we're upside down. There we go. One of the eyewitness accounts, let me see if I can pull this up. is coming from here. Here, look at this. This is Wolf Creek Crater and the Rainbow Serpent. This is a painting by Boxer Minor. And so this is the serpent, a coral snake in this case, being associated with a comet and an impact. Yeah. And here, take a look at this. This is sites of cosmic impact stories.
Oh, nice.
Or meteorite finds that are described in this paper. They're all over the country.
Yeah.
And then that graph, but I wanted to get to the account here on page 8. See if I can find it. And so.
And I imagine if some of these accounts contain the consequences of this, like, of course, if you're going to drop the temperature significantly, that's going to create a famine.
Yeah, well, we know that these stories, some of them are true. And some the most ancient catastrophe we know of is a Native American story describing the eruption of Mount Mazama, which many of you know as Crater Lake in Oregon. The natives witnessed this. This is like a VEI 7 explosion. So they didn't all die. And it was handed down in myth that is still in the legend. And then they excavated sandals under the Crater Lake Mazama ash layer, and they were dated to 6,500 years ago, proving that the natives were there. And they did witness it, and some of them didn't make it. Yes. So an example of geomythology from Australia and New Zealand is given by Bryant in a 2001 paper, who suggests that the southeast coast of Australia was struck by a mega tsunami within the last 600 years. Bryant proposed that the tsunami was induced by, guess what?
A cosmic impact.
Yeah, in the Tasman Sea, and he cites various Aboriginal and Morai stories describing tsunamis or cosmic impacts, then followed by a deluge.
I think that's probably Maori.
Maori, yeah. Specifically, the Maori story of the fires of Tamatea. That's pretty interesting.
Yeah.
So let's take a look, and I implore you all to pick up Google Earth. So here's the Tasman Sea down here between New Zealand and Sydney. And if you just come up on the coast here and pick any of these, like, let's say, whatever they're called, secluded bays, you want to be looking in here to see, whoa.
That was weird.
I don't know what I did.
I don't know either.
I pushed a button.
And it's weird that you can't back up either.
Yeah, yeah. So if you look at any of the coasts around any of the continents, what you're going to find is similar kind of sand wash-ins with chevrons, similar to what we just showed. Now, we showed you where the impactors were in the Gulf of Carpinteria. You know, that's really localized. It's going to keep that tsunami in that bay for the most part, and anything that translates out of there will be small and maybe only affect small portions of other continents. But if you start looking up almost on any of these continents, you're going to find strange structures, typically sand that washes way inland that maybe doesn't look like it should be there. This is a really big beach.
Yeah.
Now, the problem with Google Earth is that some areas on the planet here doesn't have high resolution. You see how we're getting some lines in here?
Yeah.
I think you have to pay extra money. That's probably the way it is. But I haven't even looked down here, but I figured if there was an Aboriginal story, take a look here. See these sand bands?
Yeah.
Yep.
Yeah.
And these are probably pointing towards the impactor.
Right. And they're all, of course, in the same direction.
Yeah. And that's from a wave coming in.
And there's probably more sand than that because it looks like there's quite a lot of vegetation there.
Yeah, it's only a quarter mile.
Yeah.
Inland. That could have been from a smaller event.
Sure.
Yeah. So it's actually kind of fun and and you discover things just like the video I had out last night on these new earthworks.
Sure.
And then when I was doing more research on that area, the natives knew that this particular creek in the spring, during spring runoff, flooded the entire valley. And so in the summer, they were able to make ponds and to capture that water so that they had
Nice.
it all summer
Yeah.
for growing.
Yeah.
So, I mean, there's just so much we're uncovering about what the natives knew and what they told us
Yeah.
that we really haven't been listening. Now, here's the southern coast of Australia. There is another impactor that hit the ocean out here. I'm not remembering the time frame, but take a look at some of these deposits where the sand goes in quite precipitously in some areas very far,
Yeah.
like at the cusp of bays.
Right, and I was going to say that it's not surprising that it goes in far in a bay like that, because that bay is going to amplify a wave.
Yeah, and look at the ripples all the way in.
Yeah.
Look at that. That's got to be, oh, and up here. That's got to be pretty big distance. Let's see this one. Yeah, that's 6 miles.
Yeah. And some of the chevrons that we've looked at before, let's say like off the coast of Africa and stuff, those are huge too.
Yeah, and more interesting here, there's this is an ancient shoreline right there.
Yeah.
So that would be when the sea level was the highest during the Holocene optimum, when seas could have been 110 feet higher.
Yep.
There's the ancient coast. But this is not an 8,000-year-old tsunami. This is more recent, just could be a few hundred years.
Mm-hmm.
Or this could be part of those impactors that came in 500 AD.
Mm-hmm.
Because, I mean, like, look at this. What is this? How did that sand get in there?
Right.
So it's a fun game to search the coasts to find these kind of catastrophic emplacements. And then to wonder, what did that?
Mm-hmm.
And pretty fascinating. So we've got Noah's flood that's dated to 4,807 years ago. We've got, and it corresponds to a major dip in the Holocene temperature graph. So it's a global event, and we're talking about this event now in the Bay of Carpentaria, which caused the late Neoglacial anomaly, another one of the most major cooling events in all of the Holocene. So maybe it's the most major cooling events that are the comet impactors, and the lesser events could be some of the grand solar minimums.
Right. Or they could all be impacts.
Yeah, well, that's funny that you should say that, and a good segue, and one that I wanted to finish up with here to get even more recent.
Mm.
And this is the 774 AD Charlemagne event.
Mm-hmm.
Now, there's no evidence that there's any impact during this event. But the evidence, again, comes from dendrochronology, tree rings. And it shows a massive carbon spike. Let's get to the science here. Until recently, the years 774 and 775 were best known for Charlemagne's victory over the Lombards. But recently, a team of scientists in Japan discovered a baffling spike in carbon-14 with the rings of cedar trees that matched those same years. And because cosmic rays are tied to carbon-14 concentrations, scientists around the world have wondered what the cause may be. And initially, they said it was a nearby supernova. But they didn't ever think of the sun.
Right. They didn't consider the closest star that might have novaed in some way.
No. Yeah. So they thought a gamma ray
nothing
burst.
can happen with our sun. You know, our sun is totally stable. It's the same as it's always been.
Now, what they then concluded through time, because it's been a bunch of years now, was that the energy emitted by the sun would have been, say, 1,000 times larger than the Carrington event.
Yikes.
To create this spike. It would be the greatest solar flare ever known. And if you watch Suspicious Observers, it would be a micronova.
Yes.
And this one just happened 1,300 years ago.
Right.
And guess what happened to the temperature?
I'm guessing it got really hot for a little while and then cooled off.
Yeah, so it's just cold. It's
It's
right
just cold. Interesting.
Yeah. That would be well, there's a warming during that time, and then it gets cold. The last report from Greenland, that's when everyone on Greenland froze. The Vikings all died out and buried their last people. Let's see what this graph says. Yeah, there's a warming, the medieval warm, and then a rapid cooling right around the event.
It'd be nice to look at a temperature graph in higher resolution for that time period.
Yeah, so what we have is a Carrington type event coming off of the sun times 1,000. How long would that last?
I don't know.
So the Carrington event is the greatest solar flare event in the last 200 years. And this one would be the greatest thing in the last 1,300 years or so. And it would be 1,000 times larger. So how many in-between events have happened?
Right.
And I'm sure there's a lot of trees that people haven't looked at to find these spikes.
Sure.
Yeah. So that's crazy. And they go on to talk about supernova here, but
yeah,
I don't think that the carbon from a nearby star is supernovae.
Yeah.
But Aboriginals also have there's historic accounts from natives, not only of comet impacts, but also of stars changing size and brightness. So there is so much evidence that our natives all around the world, our native ancestors, were all expert astronomers.
Why would you not be?
Yeah.
You know, I mean, you have so much time to stare at the sky,
and we call them like stupid hunter-gatherers.
Right. It's really insulting. It's so sad.
Well, thanks for joining us, folks. It's been a great show. We appreciate you tuning in. Support Revolution Radio. Number one support, listener-supported radio station on the internet. Be safe. Love you.
Listening to Revolution Radio at freedomslips.com. And we'll be right back after this message.